Hello, everybody. This is the SMC Journal podcast that you're watching. I'm Scott Moore. I'm your host of the show, and this is the show where it's all about performance in IT today. If you're a performance tester and you're used to creating automated scripts and dealing with parameterization, correlation, and things like that to test your app, is it possible to do away with all of that? Well, my next guest seems to think that that's the case. And the company in question that they represent is a company called SpeedScale. So I want to take a look at this website on Crunchbase about SpeedScale. It's a startup company that's gotten a few rounds of seed money here, and you can see they haven't been around that long. But I found out about them. There were a few articles on top Kubernetes performance testing products, and SpeedScale came up in the list. And then I noticed from the people that I saw that were part of the founders, Ken Ahrens. Well, I've known Ken for several years. I used to talk to him about service virtualization and Lisa when he was at ITKO, and most recently he was with New Relic, and now he is one of the founders of SpeedScale. So when I looked at their site, I had some questions about their technology, and Ken said, you know what, you need to talk to Nate Lee, our other founder, about that. So that's exactly what we're going to do. Let's bring in Nate, and I've got some questions for him. Hey, Nate, welcome to the SMC Journal podcast.
Thanks, Scott. Thanks for having me.
Why don't you introduce yourself to our audience and tell us a little bit about SpeedScale?
Yeah, so I'm Nate Lee. I'm one of the co-founders. My co-founders, the other co-founders are Ken Ahrens and Matt LeRae. We started SpeedScale about 2 years ago, two and some change. And SpeedScale is a startup. We were backed by Y Combinator. We help engineering teams validate how new code will stand up under production conditions. And we do this by collecting and replaying API traffic. And through this replay of traffic, we can simulate chaos, check for contracts, and then also measure performance before the code is released. We're kind of an alternative to we're an alternative to legacy style performance and integration testing that can take a while to write and are heavily script based.
That's interesting because when you say legacy means scripting, everybody I know is still doing scripting, and I look at your website and that's exactly what it says, is what you just said. Collect and replay traffic, no scripting or without scripting, and you can simulate load and chaos and measure performance. So you now have my attention. I don't have to create automated scripts anymore. So how do you do that magic?
Yeah, I mean, I don't think anybody needs to really emphasize the need to move quickly, right? We've got all these high-paid developers, and we've got a lot of um, responsibilities that are falling on their shoulders lately, like with monitoring infrastructure, integrating with CI/CD, and the last thing you really want to do is sit down and write scripts. We thought the basis of the tests should really be traffic. One, because when it comes to the process of writing tests, you're oftentimes sitting around thinking, how do my end users um, actually use my application? And the end users don't have to be your customers. They could be anybody who consumes your API, right? So there's always an increasing number of integrations against your API that you have to think about. And then also you have backend dependencies you need to integrate with. But anyways, to answer your question, the way we're doing this is we're consuming traffic, either traffic that's going through your staging environment or traffic that you've observed in the past going through your production environment. It undergoes a sanitization process, obviously for security reasons. And then we're actually parameterizing the values that are found in that traffic, things like timestamps, unique IDs, header values, authentication tokens. And those get replaced on the fly when we're replaying that traffic, because you can't just take traffic and replay it. That wouldn't work. It wouldn't get processed properly. The security, it would get rejected across the board. And so that's really the secret sauce behind SpeedScale, is understanding what to do with that traffic to manipulate it and make it replayable, both from a front end perspective coming into your API, but also we can take that traffic and build mocks out of them, sophisticated backends that simulate your dependencies.
That's exactly where I was going next, because what you just mentioned there was what a traditional performance tester would consider correlation. And that in the scripting world, that's usually the bear that bites you, right? Because you're having to figure out, okay, I've got state to deal with, and I've got session IDs, I've got all these things to worry about. So you're saying, we've solved that problem for you already, but then you also, when I think about playing back the traffic, not only from a security standpoint, but what if my traffic is spending a lot of money on PayPal throwing this third party call? I don't want to do that when I'm load testing. So how do you mock that up and avoid that situation?
Yeah, so that's the biggest thing. You know, the three of us founders have been spent a lot of time in the DevOps world. Companies like New Relic and Observe Inc. and you know, going way back, Wiley Introscope and stuff like that. So we've seen that after a lot of test automation is built and you know, there's a lot of automation that you can take advantage of. The next kind of long pole in the tent or the delay that you run into is environments. And these environments can be both, you know, just normal day-to-day stuff that you own in-house, but it gets even trickier when they're third-party connections, like you said, PayPal, or Stripe, or HubSpot, or something like that, or Twilio. And so um, we deploy agent-like technology, you know, quite similar to monitoring tools. So SpeedScale looks on the surface a lot like a monitoring tool, and these agents pick up the traffic, and we're essentially listening to how you communicate, what sort of requests you send to CheckFree, Fiserv, or whoever, and then what sort of responses they come back, and we take that traffic and then begin to model what would be a sophisticated mock of those backends. Um, like, again, with all the parameterization and understanding what needs to be replaced on response time. Not only that, those mocks are coordinated with the inbound load tests that get injected. So now we're understanding, well, you're going to get a request for this that comes in the API. And then we know your API under test is then going to make a back end call that looks for that record. And if you parameterize those and then also synchronize those, we can do what you're talking about as far as maintaining state, and avoiding the headache of having to stage that data, or after that data gets burned, having to reset that data, right? And because we are simulating those backends, it's not like you're going to get, you know, 10 transactions per second as a response, right? When really you want to go to 500 or 1,000 transactions per second from the backend.
And so, on that note, what if the backend or third party calls are the reason why my site is slow, and you want to do some kind of a litmus test between the two? Do you have a way in that mocking to slow those calls down to say, hey, if that call to this third party was 500 milliseconds better, this would be an improvement on our site? Or can we make it worse to show when they have a problem, we're going to have a problem? Are you able to show that?
Yeah, yeah. So that's kind of one of the advantages of using traffic as the base element of our testing framework. You know, the traffic, once you have it, there's a variety of things you can do with it. You can take out any sort of delays between response times. You can increase delays. Sorry, I didn't mean response times just now. I meant delays between invocations, right? But on the third parties, we can begin to interject um, all sorts of conditions. We can say, hey, 25% of the time, I want you to send back 404s. Or hey, 10% of the time, I want you to have a latency of 5,000 milliseconds. Or, you know, I want you to hold the call for 5 seconds before you respond. Um, and so in that way, we're actually causing more failures than people typically are able to do in, you know, a normal testing phase, right? We're trying to break your application from the third party backend perspective, as opposed to, you know, sending in bad input values or wrong UI values or things like that. That's typically how you try to break your app. And I think there's been some move from a lot of the cloud players to bolster their resiliency nowadays, right? I think that's why chaos testing is a big thing nowadays, in addition to, you know, conventional load and integration testing.
Interesting. So we keep talking about API testing. And
Mhm.
now I have my brethren who will say, because they are end-to-end testers and they test integrated systems, right?
Mhm.
They would say, well, even if you test all the APIs together, you still haven't done a true test on the integrated system, or the argument is, okay, we've tested the APIs, but our site is still slow, maybe because all that other stuff that comes with the website or the app is the problem. So,
Mhm.
how would we fix that? How would we solve that problem?
So we definitely talk about testing at the API level because we think that after you put everything together, there's just so many failure points, right? It's an interesting dichotomy right now because we've got people who are more remote and separated than ever, and because of the pandemic and such. Yet all the work that they do is supposed to work in a very tightly integrated fashion, right? And everything's got highly interconnected dependencies. So we're really pushing the API level, what we sometimes even refer to as component level load testing. And component level load testing is very difficult to do because you don't have the right dependencies. But having traffic based mocks that are generated off of real traffic, sophisticated mocks, really changes the game there. We can automatically identify, hey, your API talks to 5 backends. And by the way, here's a mock of those 5 backends. And so it actually is like you're doing an end to end integration test. Your API, for all intents and purposes, thinks it's in a fully integrated end to end environment, but really we're just simulating your neighbors. We're simulating the inbound coming in, and we're simulating your immediate backends that you need. None of the other environments are available. And we can actually draw up the YAMLs for you. We'll actually spin up the containers with a Kubernetes operator, and if it's a Kubernetes app. And we'll also seed the data with the correct data sets. And so if you're trying to accomplish, or your particular engineering team is trying to accomplish a more traditional end-to-end test using UI invocations coming in with through something like Selenium, or injecting load at the UI level with Selenium Grid or something like that, um, this is not that solution, right? We're really focusing on just the API level. Our philosophy being, APIs change a lot, right? And they can actually be attacked programmatically, provided that you've got the proper environment for that API to live and function. And usually that doesn't happen until the very end of your sprint, where everybody puts everything together. But at that point, it's difficult to do true performance engineering because you may find the first one or two bottlenecks, right? It's kind of like you're chasing it down, and who knows, you may run out of time. Whereas if you know this API, every single time I do a commit, it can do 200 TPS, and that API, every single time I do a commit, in terms of like continuous performance testing, I know that one can do 400. And so you've kind of eliminated variables down to, okay, if there is an end-to-end performance lag, maybe it's network, right? That sort of thing.
One of the things I can completely agree with you on is environments are seem to be the still the bane of every performance tester's existence, because we
Mhm.
got to find one, and do we know, is it like production at all, and if it's not, can we document that? How do we know if it's a percentage? It's crazy. I think Kubernetes kind of helps, because, or when you're deploying container based applications, because you just spin up another another environment and you just test it and then you spin it down when you're done. One other quick question though, one thing we didn't talk about was the reporting that comes out of SpeedScale. So
Mhm.
once I've
Mhm.
done this and I've played this back, what kind of reporting do you provide back to me to tell me, hey, here's your response times, here's where a problem might be? What's the typical report look like?
Yeah, we're kind of blurring the lines between like typical integration or contract testing, and performance. So when we're replaying the traffic, we can actually do validations for both in one fell swoop. So most people are limited, or used to doing like contract tests using something like Pack.io or Rest Assured, and then having a completely different framework, for load testing. It's a different scripting language. There's no scripting involved at all. You basically just record traffic and replay it. But the results that you get are, a tester and an SRE's dream. So site reliability engineers typically need to understand your average and 95th, 99th percentile latency, right? So that they can understand if they're going to burn up their air budget. And then for conventional, like, application developers, they're going to want to see, okay, did I break the integrations between, my back ends and front ends? And they'll want to see if there's any sort of changes between the last version of their API and their latest. So not only do we show the SRE golden signals, latency, throughput, error rate, and headroom saturation, but we also show a diff of your API responses coming back from your API. So we'll automatically walk every single JSON field that comes out of your responses and show you, well, last time you replied with this field, and this time you're replying with this different field, right? This could be a breaking contract change. And we run that as part of the normal CI/CD process, and send the results back to Jenkins or GitHub or GitLab, whatever your GitOps flow is for now.
Awesome. So it sounds like an interesting solution, and I'm going to dive into it a little bit more, and I'll definitely share some links about SpeedScale, as well as some of the reporting that I'm seeing as well. But thank you so much for being on the show and explaining this to us, Nate.
Our pleasure. Thanks for having me on, Scott. Appreciate it.
All right. Thanks. Bye-bye. Well, great interview. Let's go back and look at their website for just a second. If you look at speedscale.com, you will see an example of a report right there on the very front page and the kinds of metrics that they are talking about here. So we've got a latency summary, a throughput, some memory, CPU. So we're looking at infrastructure as well. I would encourage you to probably go out there and check out this product, check out the results, and let me know what you think. Is this an SRE's dream test result metrics? You tell me. You can reach me at scottmoore.consulting. You can also check out my LinkedIn profile there and my Twitter profile of Load Tester. And you can reach me by email at help@scottmoore.consulting. We'd love to hear your feedback on SpeedScale. Have you signed up, or actually have you liked the YouTube page? Signed up is so old school. But yeah, do you like this content? If you want to see more of it, please subscribe to my YouTube channel and let me know what you think. You can also leave comments on the YouTube videos as well about that particular episode. And this show wouldn't even be possible without our friends at Micro Focus, makers of Load Runner Professional, Enterprise, and Cloud. Performance matters to them. Did you know that Load Runner Solutions have the largest community of practitioners? Join their community at community.microfocus.com, and we have links in our show notes to them. And we also want to thank our other sponsor for this episode, Keysight Technologies and Eggplant Software, makers of Eggplant Performance. Eggplant Performance supports web, Citrix, and low-level TCP/IP-based applications for performance testings, and it's complete with real-time monitoring and integrated test results analysis. So check them out at Keysight Eggplant Performance, or check the links in our show notes. So I'd love to hear what you have to say. Check out SpeedScale. Let me know what you think. And what about those of you who are doing this integrated testing that I mentioned? What I was talking about was, instead of just testing at an API level, what if all of that other stuff in the web page, the style sheets, the client-side JavaScript, the things that are typically static who would go into a CDN, you think, well, we don't have to worry about that because the CDN handles that. Oh, really? What if your caching policies aren't right? What if your CDN is having problems? It's happened before. There are other considerations to consider. How would you fit this in? Could you run this in addition to a typical traditional load test where there is automated scripting involved? I'd really like to hear what you have to think. I'll throw the email back up on the screen, help@scottmoore.consulting, and I'd like to know what you think about that. So that's our show for today. Until next time, this is Scott Moore signing off for the SMC Journal, where it's all about performance, and we'll see you next time. Bye-bye.